All right, so we've got this technique now where we can use execute SQL and have the output be valid JSON, which is pretty cool. Um, it's one of many possible techniques that one could apply to get JSON out of data from FileMaker, and certainly not the one that I would reach for all the time. I think I would use it in some cases, but not all. If you go back and you look at the community thread that I mentioned, a lot of different possibilities have been mentioned there. And as far as I'm concerned, it's not a one-size-fits-all situation. Each of the techniques mentioned has a time and place where I would think it would be the best technique to use. But continuing our focus on this one here, my main critique about it is that crafting that execute SQL statement is sort of tedious, detail-oriented work that for me is prone to error. So the next thing I did once I got this far was I started looking at possibilities for simplifying things by writing some custom functions to handle what's really going on here. And if I were to summarize what's really going on here, it's basically step one, craft this select statement that carefully uses literal strings concatenated with other values. Step two is to actually run the execute SQL call. And step three is to do the post-processing substitution. So I wrote some custom functions to sort of take care of this stuff, and I'd like to show those to you. So let's have a quick look at the functions in the first place. There's just three of them. The first one, JSON SQL select, is the one where you specify the fields that you want and the JSON keys that you want to use, and that will generate the appropriate select statement for you, and it will appropriately protect the field names by grabbing them dynamically and the table names by grabbing them dynamically, so that you don't have to worry about things breaking should a field name change. SQL field, that's simply the custom function that you use to pass in field references into this first function. And SQL result, that's the one that does the post-processing at the end. So let's take a look at these in action. I typically use these in form of a let statement, and I'll start off by assigning some SQL to a variable, and I'll do that using the first of these functions, which is SQL select. For now, let's leave key field reference. We'll come back to that. Select field list, that's the list of fields that I want to select. Let's go ahead and add that in. It'll make repeated use of one of the other functions, which is JSON SQL field. So let's grab some fields. We're going to say we want first name. I'll give that a key of first name. Data type, that should almost be self-explanatory, but the thing about it is you don't have to specify what the data type is. You can use an empty string and it will infer it by looking at the field type itself. So you would really only use that if you want to override the data type. Let's grab a couple other things. Since I want to get different data types, let's do a favorite number. And birthday. And breakfast time. You can tell where my priorities are. All right, so that's the list of fields that we want to select. And the next thing we do is we supply a parameter, which is the clauses, the remaining clauses that we need to make our SQL statement complete. So that would be something like from people. And we'll do this. How about fetch first 30 rows only. I think there are only 26 rows, so we're going to get them all. All right, so that's what the call to JSON SQL select looks like. Specify the fields, specify the JSON keys, provide the remaining clauses, and it will return an execute SQL, or a statement that can be fed into execute SQL reliably. So that's going to look something like this. All right. Now the only other thing remaining to do is we do need to do post-processing on the return value from ExecuteSQL. So we do that with one of these other functions, which is SQL result. And we pass in the SQL result. And then we add one more argument which says whether or not we want to have the result be formatted pretty. And I like that look, so we're going to go ahead and do that. All right, so this is what the what a sort of sample application of these custom functions look like. Again, to recap, you specify the fields and the keys that you want to have in the JSON, the remaining clauses for your SQL statement that could include various constraints or an order by or something like that. And then you post-process the results. And let's see what happens. All right, we get our JSON. Again, we've done the work to have the escaping being taken care of, which is good. You'll notice that the date value and the time value are being formatted in the format that you typically get from ExecuteSQL. You'll notice that number fields are being formatted as numbers. They're not quote escaped. You'll notice that when there's not a value in a number field, it's being properly set to null. So it's really taking care of the things that need to be taken care of in order to make this valid JSON per the data that we're getting out of the table. But let's say, for example, that we don't like this date format and we want to use instead the format that we would get from the locale setting in our file or in our system. We can do that by telling the custom function to override the data type of the field that we're pulling out and instead make it a JSON string. And when we do that, it's basically going to coerce the value into a string, and when that happens, it'll use the locale formatting instead of the standard ExecuteSQL formatting. So as an example, I'm going to go to where we're requesting the birthday field, and I'm going to say that it's a JSON string instead of leaving the data type up to the custom function to figure out. We're going to override it. And when we do that, you can see that all of the birthday values have been now formatted to our locale. Similarly, we can do that with the time. And that changed the formatting for all of our times. If we wanted to override the fact that favorite number, if we wanted to have that be treated as a string, similarly we could do that. All right. And you can see instead of null here, we're now getting an empty string, and all other values have been quote escaped. So those are some little tweaks that you can do by using the last parameter in the SQL field function to specify overriding the data type. So the next thing that I'd like to look at is supposing you wanted to have a more custom structure of these fields. You didn't want to just have this sort of flat dictionary style of birthday, breakfast time, all at the same level. This is something I wanted because I'm assuming that I'm going to feed this JSON to some sort of API that might require a particular structure that's not as simple as this, and I wanted to be able to handle that situation. So to illustrate how I do this, let's go ahead and add a few more fields to our list. Let's in fact add the remaining ones. I think we've got the address fields to add. Let's go ahead and do that. So let's see, we've got street address. I'm just going to call that street. City. And state. All right, and let's see what that looks like. No big surprises. We've got our added fields in the JSON. I should mention too, by the way, that the order of these statements here is arbitrary. As long as you feed in what you want, it's going to look for them and find them. And by the time it gets into your JSON, it's going to be ordered by alpha anyhow. But it's not like you have to be very crafty about what order you put these things in. It just works. So let's look at making some sort of a more custom structure. And I'm going to start by let's put the name fields. Oh, we're missing last name. Let's add last name too. Alrighty. let's put the name fields into a person subobject. And we'll do that with dot notation for our JSON path. So person dot first name is going to put it into a sub object of person. And let's see what that looks like. So with that one little change, we can see in our output, we've now got a person object here, and that's where we've moved our first name and last name. And it's all just basically based on path. You can do whatever sort of path you wanted, and there it would appear in your output for all records, of course. Let's go back to what we had. So let's illustrate it just a little bit more. We'll put the address into something like location. State should go in location. And let's put favorite number and birthday into personal. How about that? All right, I kind of think breakfast time should go in there as well. Let's do that. Let's put breakfast time in the personal.meal. Okay, so now you can see we've been able to customize the structure of the output just by specifying the path that we want to use when we call these functions, which I think is pretty helpful. It means that, I'm more able to use this with a variety of different APIs because I'm not fixed into just this sort of standard dictionary key value format. I guess the next thing that I could show here is it works just as well with related data. So if we had some kind of join in here, I've got a related table, it's a foods table, and we can pull food name out of here. And let's put food name under, we had something that was meal, right? Yeah, let's do this. We'll put food under personal meal, favorite food. So we're pulling that field now from another table, but there's nothing really mystical about that. It's just a join. We're going to take care of that here. Let's see. I think that's going to do it. We'll find out. All right, so there you have it. We've been able to pull in data through a join and have it appear in the structure, no problem. Not really any surprise there, but I did want to illustrate that. I guess the last piece to illustrate, let's go back to the main table, is right now we're looking at this stuff, and it's, let me see if we can take a look at it. It's something a little easier to see. We're looking at a JSON array of all these different objects, right? And supposing we wanted to have a dictionary structure where each of these objects was available through a particular ID, something that uniquely associated with each particular record, and that of course would be our ID field in this case. We can do that, and let's see what that would look like. Basically what it would look like would be using this first parameter that we've so far ignored. You specify the key field, and then you run it and take a look at the result. This time what we have is a JSON object, and the key for each object is the key from the record. And so you basically have a structure where you could pull out a particular record at will if you know the key. You'll see that these are numeric values, but that's just a result of the fact that I was using serial numbers for my keys and not UUIDs or something else. But they are strings in this case, or they're at least handled as strings in the JSON, and so they could be whatever kind of key that you've got in there, as long as they're unique. That's the requirement. So I think that's sort of like the quick tour of these functions. If it's something that interests you, I'll be posting up a sample file like this one so that you can check them out, and that's pretty much it. Thanks for taking a look.